Hi, my name is Miloš and welcome to Element 14 Presents. Today we'll use an old air fryer that I found at the flea market for 10 bucks and turn your prints going from this to this. We'll explore how that air fryer works, we'll wire it up with our own electronics, and we'll make it an IoT device using Arduino Cloud. Let's dive right in. If you watched any of my previous videos, you know I use a lot of 3D printing for my projects. Prime example here, Perry the Platypus bot. The blue plastics here are PTG and the rest is PLA. Both of these are great because even if they get a bit wet along the way, they won't change their properties a lot. But there are some other filaments that are quite more difficult. Something like TPU, and you've seen that with this benchy here. That's also true for nylon. They get extremely wet and the printing quality just degrades rapidly. You can even hear it when the nozzle is extruding the filament, like I'm gonna play in the clip now. You can literally hear the bubbling and the crackling sound because of all of the moisture in the filament. There are a lot of off-the-shelf options to tackle these filament dryers that are 50 to 100 bucks, but for just 10 bucks I found this old air fryer at the flea market, so I thought, why not convert it to a filament dryer and see what kind of results we can get. Before we get into those electronics, let's just figure out how this thing works so we can modify it. Here is the air fryer I bought at the flea market for 10 bucks. It's a really good find. So let's take a look at the main components of this air fryer. We first have the plastic stand, we have the glass bowl, we have the lid that houses all of the electronics in, and we also have this metal grate, which is great for keeping the filament off the ground and generally having better airflow around the filament. So how this works actually, if we take a look down here, we have a metal fan that's literally just circulating the air inside this glass chamber, and we can see a heater here. How this usually would work is you would set the temperature and the time with these two knobs here, so it's completely analog and it would just work. How accurate it is, now that's a different question because you don't need to be that accurate when you're air frying food, but we're gonna utilize the heater and the fan here and replace all other electronics with our electronics. Let me show you the plan on how I'm gonna modify this to make it into a filament dryer. First, let's draw the air fryer that we've just seen on the table. We have the two main parts, the glass bowl, and we have the lid with the electronics. To that, we will add the 4 metal posts so we can elevate the electronics box from the heat of the heater and from all of the high voltage electronics, and have our custom electronics in the box on the top. We will also use another thing that you've seen in the video, that's the metal grate, to keep the filament off the floor so that there's better air circulation, and we'll add some desiccant to the bottom. Now onto the electronics. As the brain of this thing I will be using an Arduino Uno R for Wi-Fi. I want to make this an IoT device and we're gonna use Arduino Cloud since it will enable us to make a dashboard really easy, as you will see later in the video. Besides that, we need a temperature sensor so we can actually control this. And now we can get to the power electronics, with the main thing being the master relay. One thing here that I need to point out, this is a disclaimer, you're gonna be working here with mains voltage if you want to recreate this. There is a risk of injury or death. Proceed at your own risk, but please be careful if you decide to follow along with this project. The master relay is here to ensure that it's a relay we will switch at low frequencies that we can cut off power to the rest of the system. Besides that, we will have 2 more relays, an SSR or a solid state relay for the heater and a normal relay for the fan. Why we are using an SSR for the heater is that we can safely switch it at higher frequencies without having the danger of it getting stuck like it can happen with a normal relay when you switch it at some higher frequencies. So that's why we're using an SSR, and just to be safe we have the master relay, as already mentioned, that can cut power off from both of those relays. Now that you have an idea of what we're making, it's time to wire it all up. We're gonna be using an Arduino, not this thing because this is the OG Arduino Uno R3, we're going to be using the newer and much more powerful version, the Uno R4 Wi-Fi, since it already has built-in Wi-Fi capabilities, and we're going to pair it with Arduino Cloud, as you will see in a bit. But before we get to the software side, let's first take care of all of the wiring and hardware. Now that we know what we're making and what we will be using, let's see how we're going to connect it together. As already mentioned, the main thing here will be the Arduino Uno R4 Wi-Fi. It's more than powerful enough, and we also have Wi-Fi, so we can make it an IoT device and connect it to Arduino Cloud, as I will discuss later. Warning again, we will be working with mains voltage here, so be careful if you want to recreate this. This is the AC connector, and this is just a 12-volt power supply, which we will connect either to the wind pin or the barrel jack, which are connected together. We have the temperature probe here, which is just we're communicating with this IC here, the MAX 6675 over SPI, to get our temperature readings. One thing to note here about this temperature probe, make sure that it's isolated from the grounded parts of your air fryer, since it won't work if it's touching any kind of metal. For this reason, I will just use some heat shrink. And here we have the relays that you've already seen in the drawings. So it will be 3 relays, a master relay for safety reasons, a solid state relay because we can switch it at higher frequencies without worrying about it getting stuck on, which will be a bad day for the heater. And we have the fan relay, which we will essentially just turn on and off every time the program is turning on or off. Here are all of the electronics wired up. As you can see, I tried separating the high voltage part, which is at this lower part of the box, from the low voltage part with the Arduino here. So from the beginning we have the AC connector down here that's connected to our power supply, which converts the mains voltage to 12 volts so we can power the Arduino over the barrel jack. That 220 volts is also going to the main relay, which then switches that power and is then powering the fan relay and the solid state relay, which is actually used for the heater. In that way we actually have the master relay in series with these two, so that if we for some reason want to kill the whole thing, we can just switch off the master relay, and we know that neither the fan relay nor the solid state relay will get power, so it's just another step to safety. Besides that, we have the temperature sensor that you can see here, and up here we have the Arduino. I tried keeping everything as neat as possible, used the ferrules everywhere, and the Vago connectors just to make it easy to work on if I want to add anything later on, like manual control, stuff like that. But it's pretty safe, everything is tied nicely, so that would be it for the electronics. With the hardware complete now, let's turn our attention to the software. Usually this would mean going to the Arduino IDE and programming the Arduino, but this time we're going to use Arduino Cloud. So what's the difference? We're going to be writing the same kind of code, so it's going to be the same sketch. You have the setup, you have the loop, nothing has changed there, but we're going to have much more capabilities for the IoT side. We can create a custom dashboard that can interact with our Arduino. We can even send updated codes to the Arduino over the air, no need for USB cables or anything like that. And it's fully integrated with Arduino, so it's pretty much plug and play with just minimal setup needed. That will guide you on the website itself. So let's go and check out how I did that and how you can do that as well. We're on my Arduino Cloud now, and we're gonna check out the code for the filament dryer. So what you want to do is go to devices first and set up your device if you haven't already. It's a straightforward process with a wizard that will guide you. Then you can go to things and create your new thing. I have the maker subscription, so I can have more things, but the free subscription also allows you to have 2 things. And let's check out the filament dryer. A great thing about Arduino Cloud is, as you will see now, are the cloud variables that you have here. And you can simply add them by giving them their name, choosing their time, whether it's energy, time, what have you. There's a lot of options here, and you can also put it to be read and write, read only, and how often it updates. Is it periodically or is it on change? That's really useful, as you will see along this video, as we will connect this to the dashboard that you can make using the Arduino Cloud. But these are some of the variables that I will be using for this project. Now, if we go to Sketch, this is the whole sketch for the Filament Drawer project. You will have two files. One is the thing properties, and it will automatically add you all of the cloud variables, and this is how you will actually connect everything to the dashboard, which we'll see in a little bit. It generates you a bit of code like this, but essentially you still have the setup and loop functions which you would have in the normal Arduino IDE. So the code is rather simple. We have the MAX 6675 IC that we're communicating with to get the temperature over SPI, and we are controlling two relays, a master relay, a fan relay, and a solid state relay, which we will be still controlling just like a relay, but you can also do PWM if you want. Essentially, here are the functions for doing that. It's a relay function that just takes three parameters, and depending on them it either turns on or off the relay. Nothing special happening in the setup. We're just getting the serial started, setting up all of the pins, doing stuff like this, Arduino Cloud print debug info, just some general stuff that Arduino Cloud will automatically generate for you. And here we have the loop function. Some of the things that I tried doing is putting some parameters here. So what I want to check for is that whether, since the temperature sensor is rather slow, it can change about 1 or 2 degrees max when the heater is on or when you're trying to cool it off. If delta is more than 5, that means that the sensor readings, something is wrong with reading the sensor, and we want to kill the whole thing since it's working with a heater. Also, if the temperature is showing under 5 degrees Celsius or if the temperature is above 150 degrees Celsius, something went wrong, and we just want to shut off the master relay and also the solid state relay. So those are the first things that I will be checking after measuring the temperature here. And besides that, there's just some simple logic for controlling the heater. It's really rudimentary now. You can make it much more accurate. This will highly depend on the thermal mass of your heater. I just put a hysteresis of around 10 degrees Celsius, and as you will see, it provided really good results. Can I tune it further? For sure, but not something that I need to deal with now since it's working rather nicely now. Another thing that you will get generated by the Arduino Cloud are these functions down here. These are the functions when you put the variables to on change, that you can also read and write them. When variable change is detected, it will actually call one of these functions. So for example, when this switch is toggled, we can detect it here and just simply change all of the parameters that we want. So the code is rather simple. You can find it linked below in Element 14 community. Let's now go and check how what's the dashboard and how we can connect it to this code. Another great thing about Arduino Cloud is this. So you've seen the code, and this dashboard was literally drag and drop, as I will show you, and it's connected to all of those variables that you've seen and to our code. So here you can see the live temperature now from the Filament dryer that's running currently, drying some TPU. You can see the temperature changing here in real time, and you will also notice how these indicators here will change depending on if we want the heater on or not, and how this percentage changes as the time goes on. So if we go to edit, we can actually see the desktop view, and we can also see the mobile view. So this is how you would see this on a mobile phone in your app, which is also really nice, so you can check your Filament dryer when you're not at home. How this actually works is, here you have a bunch of different widgets you can add, from images to maps to LEDs, switches, anything you can imagine, and they're really easy to set up. For example, let's take a look at current temperature. If we click the gear icon here, you can here change to which variable it's connected. So these are all of the variables you can connect to it. You can then choose your icon, stuff like that. So it's really easy to get started with, really easy to use, and you get a really effective dashboard that just simply works without you having to do anything else. There's another cool thing about Arduino Cloud that I'm going to show you now, and that's triggers. What triggers are, you will see in the next clip. What triggers are outside actions that can be performed based on the variables on Arduino Cloud, and they are really cool. So far you can do emails and push notifications, those are the actions, based on your device status or cloud variable. Why this is useful? So for example here, I have a drawing aborted variable, that's a bool variable that I switch to true if any of the error mistakes is detected as you've seen in the code. And if it changes from false to true, this is then activated. When this is activated, I will get a mail saying that there is a filament drawing error, and I will also get a push notification on my phone so that I can go and investigate what has happened, which I think is important for a system like this. Besides the filament drawing error, I also have the filament drawing complete, so that I know that the filament drawing process has actually completed. Here are a few screenshots of how those notifications and emails actually look like, and they work really nicely, and it's a great thing that you can do all of that straight from Arduino Cloud without having to do any other kind of integration. So that would cover everything when it comes to the Arduino code. So we've covered the hardware and software. Time to test out the whole project. And our filament dryer is finally complete. Here is how the finished unit looks like. It needs a bit more work to just cover the motor and all of the wiring here, but I wanted to have this box on these stands here to keep it away from all of the heat and to keep all of the wiring organized above here. I'm really happy that this case has a transparent lid. I love the look seeing the relays flash on and off, stuff like that. As you've already seen, here is the full wiring. I tried keeping it neat, but it's a bit of a mess here still. Everything's secure and nothing will be falling out. The last thing to do is, of course, to test it out. For testing, I'm going to be using two different filaments. First is nylon and second is TPU. So let's see what kind of results we can get with our custom filament dryer. Finally, time to do some testing, and I will be doing that on two types of filaments, TPU and nylon. If you want to find out the exact filaments I'm using, they will be linked down below in the Element 14 community, and we're going to begin with nylon. So if you remember the clip from the beginning of the video of that sizzling sound, that was this nylon. Let's play this again. And let's play that after the drying process. As you've seen, that's much better. So for nylon, I dried it at around 90 degrees Celsius for about 5 hours, once 3 hours and an additional 2.5 or 3 hours, I can't remember. Here's a quick time lapse of that. And the drying process went relatively clean. I could check the graph on the dashboard, everything worked great. I will be doing two test pieces. One is a Warren cube and the other one is the infamous benchy, of course. Let's begin with the cube. So the first cube, as you can see on your screen now, kind of failed a bit midway, but we can still see what we need to see actually. And you can see how the texture is rather bubbly. And now, after the drying process, you can see that the cube is much better. I'll have some B-roll footage for you so you can see the exact comparison. You can see that it doesn't even look like the same filament. This one is so much whiter than this one. This one is actually kind of transparent when you look at it, just because there wasn't so much bubbling. Now, if you look at the benches, it's the same story again. You can see that the general print quality is just so much worse. There's a lot of bubbling, stringing. And if we look at the other benchy after the drying, again, you'll have the close-up B-roll footage of this. You can see how better the print actually looks like. So for nylon, this is a home run win if you ask me, and it opens up the possibility for me to actually do useful nylon prints, which is a really good material for something like gears and stuff like that. And maybe you'll see some of those in the upcoming videos. Now it's time to switch up to TPU. So the same tests again. First we have the Warren cube. As you can see, it's like I applied the fuzzy skin texture. It stayed out for a couple of years at this point, so it had time to gather a lot of moisture. And here is the new one. If you ask me, this is a night and day difference. Again, there will be a B-roll close-up and you can see how much better it looks. And also if you look at the benchy, the difference is night and day. So I think that this project was a really big success, and it's something that I will be using for sure for this kind of filaments and other more exotic filaments like PCCF, polypropylene and other stuff. Thanks so much for watching me build this filament joiner out of the old air fryer. So if you have any questions or comments, please leave them down below. Please be careful again if you try recreating this, because again, it's working with mains voltage. So be careful, but I'm really happy with how it turned out and the results are really good, as you've seen both for nylon and TPU. Until next time, see ya!